Today we're going to be solving exponential equations. The very first step is to use the property of exponents to simplify each side. So guys, this one and this one are already simplified. Let me show you an example real quick. If I have x squared times x cubed, what does this become? X to the fifth power, good. You added the exponents together. In the same way, we're going to use that same rule over here. The bases are the same and we're multiplying. That means we can do one base and we're going to add the exponents, just like I did up here. So k plus k is 2k. And then I have the plus 2. So that is what step 1 means. Use the property of exponents to simplify each side. Over here, my base is 10. And I'm going to add the exponents to get what? Good. Same on this side. I'm going to add the exponents. What is v plus 2v? 3v. And 4 plus a negative 11? Negative 7. So guys, that is how you do step 1. You have to use the property of exponents to simplify it. Okay, now let's move on to step 2. Rewrite the equation so both sides have the same base. All of these problems have the same base already. I have 10, 10, 5, 5, 2, 2, 3, and 3. So we can skip step 2. We already have the same base. Step 3, drop the bases and set the exponents equal to each other. So cancel out the bases. We're going to set the exponents equal to each other and solve. So I'll subtract 1 from both sides, and I get x is 8. Over here, I get 4n plus 5 equals n minus 7. We're going to go ahead and solve. So I will subtract n from both sides. So I get 3n plus 5 equals negative 7. Now I'm going to subtract 5 from both sides. And I get 3n equals a negative 12, then divide by 3. Your answer is n equals negative 4. I'm going to let you guys do the last 2. All right, guys, thumbs up if you got 1 and 4. Nice, good job, good job. Okay, let's move on. We're going to still solve exponential equations, but notice my bases are not the same anymore. My bases aren't the same like they were previously. So look what I'm going to do. For this first problem, to make the bases the same, what should I put as my exponent so that it equals 36? A 2, because 6 squared will give you 36. So I rewrote the problem so that my bases are now the same. You guys see that? Okay, so if I go back to my steps, use the property of exponents, we didn't have to do that, but we did have to do step 2. Make both sides of the equation the same base. So if I were to go on, I have 2 to the power of p minus 7. How would I rewrite the 8 with the base of 2? Yep, 2 to the power of 3. Good. What about this one over here? This is a fraction. Uh-oh. How do I write this 7? Yep, a negative 1. Because that would flip to be 1 over 7. Okay, I'm going to do one of these at the bottom. Let's look at this one right here. I have 4 to the power of y plus 2. How do I rewrite the 16? 4 squared is 16. And you still have this exponent here. No, this is already okay. I didn't have to change that. 4 squared is 16. Okay, so with all of these, when you rewrite the base and the bases match, You just set the exponents equal to each other and you solve. So go ahead and solve these. For this one over here, those cancel out. So look what I have. I'm left with y plus 2 equals, distribute the 2. This is 2y minus 6. A lot of people forget to distribute the 2 to the second number. I see a lot of people only distributing it to the first item. You just distribute to both. And then go ahead and solve. So I'll do a few of them. Look up and check when you're done. All right, guys, for this one, what I did was divide by 4, and those cancel. Divide this side by 4. So I get 16 equals 4 to the power of 4x. To get the same base, I'm going to write 16 as 4 squared, and this side will stay the same. Now that the bases match, I'll equal the exponents to each other and solve. So I get x is equal to a half. The other way, if you wanted to use the property, this is to the 1. So you would add the exponents. This would be 4x plus 1 equals 64, which you can write as 4 cubed. So your bases match. This is 3 equals 4x plus 1. Then you would subtract 1, and you get 2 equals 4x. Divide by 4, you get a half. So you can either divide by 4 in the beginning like I did, or you can use the property where this is the power of 1, and then you just add them. You get 4x plus 1. Oh. You could also do it that way. Yeah. Next one. Look up and see if you got it right. I'm going to make all the bases a 7. So how do I rewrite 49 with the base of 7? Good, 7 squared. And then keep the x minus 5. This one can stay 7. Now, how do I rewrite the fraction? Perfect. Okay, now guys, I need to use the product property here. The product property. These bases are the same, so what do I do to my exponents? No, I add them. So this is 2x minus 10. And this is x minus 9. I have to add them. What is 2x plus another x? 3x. What's negative 10 plus a negative 9? Negative 19. Equals 7 to the negative 1. Okay, now my bases match on both sides. So I just set my exponents equal to each other. And you solve. So I'm going to add 19 to both sides. I get 18 equals 3x. Divide by 3. X is 6. Now we're going to solve logarithmic equations. First, we're going to condense each log. This first one is already condensed. Uh-oh. This first one is already condensed. Let's condense this one over here. Remember, the coefficient can become the exponent. So I'm going to write the 3 up here as an exponent. And guys, what is 4 to the power of 3? 4 times 4 times 4? 64. This is what it means to condense the log on both sides. Okay, this one is already condensed. Over here, find this one on your page. This 2 can come up here and be the exponent. What is 6 squared? Good, so this becomes log base 3 of 36. I'm not done condensing. What property do I use here? Quotient. That means I divide. So what is 36 divided by 4? 9. Don't forget to write a single log. Log base 3 of 9 is what it condenses to. This side can stay the same. So guys, that is the very first step of these. You need to condense it, where you just have a single log on both sides. So now, we did step 1 for all of them. Now let's move on to step 2. Step 2 says use the one-to-one property. If logs of the same base are equal to each other, then you can just equal the insides. That's what it's saying. Those can cancel out. You just have m equals n. So in the same way, I have log base 5 and a log base 5. Just set the insides equal to each other and solve. I have log base 7, log base 7. Set the insides equal to each other and solve. I'm going to do this last one right here with you. Okay, so of course, guys, y'all know how to solve these. You just add 8, you get 72. Divide by 4. I believe this is 18. 18 times 4, yeah. Okay, so let's do this last one together. You have log base 4 equaling a log base 4. So I'm going to cancel those out. So I'm left with m squared equals 18 minus 7m. You're going to have to factor. So I'm going to move the negative 7m to the other side. And what will it become? Yep, it will become positive 7m. I'm also going to move this 18 to the other side. What will it become? Yep, a minus 18. From here, you're just going to factor. Can y'all tell me two numbers that multiply to negative 18 but add to 7? Exactly, 9 and negative 2. So those are my factors, m plus 9 and m minus 2. When you solve, you get m equals negative 9 and m equals a positive 2. So we solved it. That is step 3. Solve it. Now, the last step, we're going to check for extraneous solutions. Okay? So let's try that. I'm going to test the negative 9 first. If I plug in, let me erase this so we can see the original problem. If I plug in a negative 9 right here, what's negative 9 squared? 81. So I get log base 4 of 81. That's okay. If I get a negative inside the log, that's wrong. It's not an answer. Remember, you cannot plug negatives inside of a log, okay? Well, if you plug in the negative, it can't stay negative. So I'm going to plug this negative 9 in right here. What's negative 7 times a negative 9? Is it positive? Perfect. So this whole thing is positive. So this is an answer. Let's plug in the 2 and make sure that it remains positive. So if I plug in 2's into the original problem, a 2 here and a 2 here. 2 squared is 4. That's positive. If I plug in a 2 here, I get 18 minus 14. Is that still positive? Okay, good. So these are both answers. Yes. If you get a negative anywhere inside of a log, it's not an answer. It's extraneous, but these two work. Okay, an example of something that is extraneous. Those cancel. We have 6 minus 3w equals negative 2w. I can add 3w to both sides, and I get 6 equals w. However, look, if I plug in, change that w to that 6, what's negative 2 times 6? You cannot have a negative number inside of a log. So this is extraneous. There is no solution. No solution. All right, let's move on to this one. Okay, so previously you had log with the base and something equals log with the base and something. We already did that type. Now we're going to do the type where it's equal to a number. Okay? So when it's equal to a number, these are the steps. Can you guys pick one of these problems that you'd like me to do on the board? Number 11. Okay. Log base 2 of x minus 4 equals 6. So it says condense and isolate. That's already done. Now we're going to write the equation in exponential form. How do you write this in exponential form?
2 to the power of 6 equals x.
Exactly. 2 to the power of 6 equals x minus 4. Now it's just algebra 1. What's 2 to the 6th power? 2 times 2 times 2 times 2 times 2 times 2. Yep, 64. And then you just add 4 to both sides. And you get 68. Now, you need to check for extraneous solutions. If I plug in a 68 right here, will it still be positive on the inside? Great, so that's an answer. Is there another one on this paper you'd like me to do?
16.
16.
12, sorry. 12. Let's just do all of them.
Okay, let's do 13. Log of 2x plus log of x minus 5 equals 2. Now, let's look at the steps. Step number 1, what does it say? Condense. So guys, I need to use the product property. I'm going to condense it into a single log. I'm going to do this times this. What is 2x times x? What is 2x times negative 5? Good. Okay, so we condensed it into a single log. Let's go back to the steps, Dwight. All right, next we're going to write the equation in exponential form. How do I write this in exponential form?
10 to the power of 2 is equal to 2x.
Exactly. You remembered that your base was 10. Remember, base of 10 is not written. So 10 to the power of 2 equals this. Guys, what's 10 squared? 100. I'm just going to put 100. Okay, I'm going to move this to the other side, make it a minus 100. Now I can factor. But before I do that, guys, can I divide by anything?
No.
Yep, divide by 2's. So this becomes x squared. 10 divided by 2 is 5. 100 divided by 2, that's 50. So I want two numbers that multiply to negative 50, but add to negative 5. That's negative 10 and 5. Negative 10 times 5 is negative 50, and if you add them, you get negative 5. So my factors are 2 times x minus 10 times x plus 5. So what will my solutions be? Just 10 and negative 5. Not 2. That's just a constant. The 2, if you set the 2 equal to 0, is that a true statement? No. But if you set these equal to 0, you can solve. So those are my two answers. Now, we have to check for extraneous solutions. So if I go back to my original problem up here, guys, go back to the original problem. If I plug in a 10, am I okay? Yeah. Okay, great. Those remain positive. If I plug in my negative 5, if I plug in a negative 5, what happens? Is that okay?
No.
No, you cannot have negatives inside of a log. Your only answer is 10. The negative 5 is extraneous.